Hello, today we're going to be looking at some graphs. We're going to be looking at log graphs and exponential graphs, and we're showing that inverse relationship that those two graphs have with each other. Now, the reason why sometimes we use inverses is not all calculators let you write in y equals log base 3 of x. Most do now, but not all of them do. So I may not be able to just go to my calculator and hit in log base 3 of x. So what I want to do is every calculator can write in the exponential equation. So we're going to write the inverse equation to get the exponential. And in case you forgot from previous units, the inverses are done in two steps. The first step is switch x and y. The second step is to solve for y. And we did this earlier today, and that is simply to rewrite into exponential form, our loop-de-loop. So step 1 is to switch the x and y. So from here, this is now going to become x equals log base 3 of y. Step 2 is I want to get y by itself. This is your loop-de-loop, so it's 3 raised to the x power is equal to y. 3 raised to the x power is equal to y. And I don't know why that bothers me, so I always rewrite it going here. So what we want to do to graph this is we want to make a t-table for it to get those values. So in our calculator, we have our y equals, clear out anything that you have in there. I want to type in 3 raised to the x power. And remember, this is the button right here that raises to an exponential, the caret. So 3 raised to the x power. Make sure that you're using the x next to the alpha button. And then to get to the table, we're going to go to second graph. Because we can see in blue, that's where it says table. I'm going to start at a -4. So we're going to enter these values into our table. -4.01, -3.04, -2.11, -1.33, 0.11329, and then that's it. So again, based on our calculator, we've got -4.01, -3.04, -2.11, -1.33, 0.11329. Okay, so this is all for the exponential equation, y equals 3 raised to the x power. Again, here it says this is the inverse equation. We found that inverse. Step 1, switch the x and y. Step 2, solve for y. So we can go ahead and go to our graph and plot these points. -4.01, -3.04, -2.11, -1. Oh, now we're at a third. We're moving up a little bit. 0, 1, 1, 3, and 2, 9. As we plot these points, notice that we have y equals 0 as the asymptote. And this should be familiar. We talked about exponential growth and decay and about how those graphs have those asymptotes. So it makes sense that we have this asymptote here at y equals 0. I'm also going to label this on my graph so that I don't forget which one is which. So since maybe not all of us have the ability to enter the log into our calculator, we found the inverse equation. So now we're going to find the t-table for the original. If you remember, when we first learned about inverse equations, the very first thing we learned was inverse relations and how easy it was to graph an inverse because all we do is switch the x and y coordinates. So this is really 0.01, -4, 0.04, negative 3. 0.11, negative 2. And again, so if you don't have the ability to put the log in your calculator, you will find the graph by doing the inverse. We go ahead and plot this. So 0.01, negative 4, really close. 0.04, negative 3. 0.11, negative 2. 0.33, negative 1, and then finally 1, 0, 3, 1, and 9, 2. So notice that the log is not going to have that horizontal asymptote. If you remember way back when we first learned about inverses, we learned that inverses, as we just mentioned, we find the inverse relationship by flipping the x and the y, which is coming about from the reflection over the line y equals x. So you can see how that graph is reflected over that diagonal line. Well, when that happens, it also reflects that asymptote. So now I no longer have a horizontal asymptote, I have a vertical asymptote. And that vertical asymptote, because it's a vertical line, is going to be at x equals 0. I'm going to make sure that I label this as y equals log base 3 of x. We talked about domain and range with our exponential growth and decay the other day. So this time we're just going to be looking at the domain and range for the original log equation. The domain, remember, is your movement left and right, and since I'm only looking at the blue graph, my log graph is only going to exist right of the asymptote. It cannot be equal to 0 because 0 is the asymptote. X's are going to be greater than 0. The range, though, I'm forever going down, I'm forever going up and to the right. Remember, it's subtle, but it is still going up. So my range is going to be all real numbers. All right, now let's see if you are one of those lucky people that have this in your calculator. I'm just labeling that vertical asymptote. If we go to our calculator, and if you hit the math button, we're actually going to go all the way down. So I'm going to arrow up because when I arrow up, it brings me all the way to the bottom of my list. And I see at the bottom of my list, all the way down, under A, I have log base. If I enter there, I can enter in a log base 3 of x. And obviously, I'd want to do this in my y equals. So let's do math log base 3 of x. And you can see what we just found on our calculator. Now notice how it stops. Your calculator does have a little bit of limitations. When it gets so close to the asymptote that it can't actually graph it any closer without touching it, your calculator just kind of stops. Please know that as we graphed, that line is going to continue to get closer and closer to the line. Your calculator just kind of shorts out on you. Okay, that is all that I have for you today.